Hi, I'm Chem's best friend and welcome. Please like and subscribe to my channel. If you would like to know how to contact me, the information is on the bottom of your screen. Let's get started. You're probably studying chemistry, study of chemistry, and you need to know how to deal with uncertainty, measurement, and significant figures. So let's learn how to deal with them. Let's go to my screen. Here we have a graduated cylinder, and you were asked to say how many milliliters of liquid, let's assume it's water, is in a graduated cylinder. Well, what can we say? Can we say, well, first of all, let's look at tick marks and realize how far are they apart. If this tick mark here is 15 and this one is 20, that means that every one of these tick marks is 1 milliliter apart. Right? Okay. So can I say that I have 17 milliliters? Well, let's look a little bit. I know it's a little bit more than 17. So let's think about what are we certain of? What are we certain of? I know that my liquid, the water, is somewhere between 17 and 18 milliliters. That is I am certain of. So I know it's a little bit more than 17. And now how much more? So in my mind, I'm going to imagine 10 little tick marks right here between 17 and 18 mils. And I'm going to use my imaginary tick mark to write something that I am uncertain of. So what if I say that it's 17.1 milliliters? What if you are looking and you say, no, it's 17.2 milliliters? And what if we have a friend that says it's 17.3? Who is correct? Well, the truth is, every one of these measurements right here is correct. Why? Because we have our certain digits and our estimated digits. So what is significant digits? They are your certain plus the last one is your estimated. They are significant digits. They tell me something about the equipment that I'm using. So here is a very important thing. You cannot report a measurement that's, I'm going to say, better, more accurate than the equipment you are using. You will be limited by how good the equipment is. So when you report your measurement, you have to say, what are you certain of? What do you estimate? And that gives your reader a very good idea of what equipment you are using. Okay? So all of these are correct. Saying it's 17, no, it's not good because you know it's a little bit more than 17. Saying 18 is not good because you know it's less than 18. So right here, our estimated digit will be the tenths of a decimal point. Okay, ready? A little bit more. So here we have usually our liquid will not be just a straight line. We will be reading the bottom of meniscus and another example. So if our 20 mils is here, the bottom, and we're going to look 25. So each tick mark here is 1 milliliter apart. So what do we know for sure? We know for sure that our water is between 21 and 22 milliliters, yes? So now we can say, well, let's estimate. What if somebody says it's 21.5 milliliters? What if your friend says it's 21.6 milliliters? Is this okay? You can actually even accept probably 21.4 milliliters. All of them are correct. Why are all of them correct? Because they have certain, something you are certain digits, and the last one is my estimated. They are all significant digits. So this is the correct. Saying something is 21, you know it's more. 22, you know it's less. Not good. Let's go to a ruler example. Let's look here. You try to measure the length of this blue block. All right. Let's look here. Well, we have, first, let's look at our tick marks. Our tick marks are every 0.1. Do you see it? 0.1. So we gotta zoom in here. We have to zoom in here and we have to like imagine little 10 tick marks between here and here. And then we have to report. Okay. So we know that it's very, very close to 0.9. But then my tick marks will go to the hundredths place, right? So I can say that this blue block is 0. Can I say it's 89 centimeters? Well, what if somebody says it's 0.90 centimeters? What about 0.91 centimeters? And what about 0.9 centimeters? Well, these are all correct. This one is not. And the reason is 0.9, you can tell better than that. You remember you have your tick marks at every 0.1 centimeter apart. So you can now imagine the hundredth tick marks. So you can actually give a little bit better estimated digit. So saying 0.90 centimeters is correct. Here, just a scale, let's say a scale in a bathroom says you have 56.1 kilograms, 56.1 kilograms. Please make sure you report that in your lab notebook. Here we are measuring chocolate on a kitchen scale or maybe a scale you have in your lab. And if a scale says it's 49.0 grams, I looked here very, very closely and it says 49.0. Please report in your lab notebook 49.0. That means 49.0. That means your scale is uncertain about the zero, right? It could be 48.9 grams. It's probably in between 49.1 grams, somewhere between there, and your scale is doing estimating. If you just put 49 grams in your lab notebook, that means it can be 48 or maybe 50 grams. We will deal with the zeros at the end. So please make sure you put down what your scale says. Please make sure you put down that 0.0. It's important. Okay, so we learned how to report our measurement. Remember the digits you are certain of plus the estimated digits. They are significant digits. And then how do we know which ones are significant? Well, let's go here. Every non-zero digit within a measurement is significant. So that's easy. So we have 91 centimeters. It's 2 significant digits. Here is 123.45 kilometers. 2 significant. Right? That's actually right there. So this is 2 sig figs. This is 3, 4, 5 sig figs. Okay. Zeros between 2 significant non-zero digits are significant. They are called trapped zero, or some people call them sandwich zeros. So look at this zero. It's between 2 non-zero digits. Again, here is the zero between 2 non-zero digits. That means these zeros are significant. So here we have 3 sig figs, every one of them. We have 3 sig figs here in this measurement, and here we have 5 sig figs. Remember, we are uncertain about the 5. We are uncertain about the 8. That 0 is just very important there. Okay, so the problem comes with zeros at the beginning and at the end of a number, right? So the zeros at the beginning, really no big deal, because zeros at the beginning to the left of the first, the leading zeros are not significant. Now, why? They are called placeholder zeros. Let's look at them here. If we have 0.091 kilometers, I can change that unit to 91 meters. So I cannot say that this is 4 sig figs and then change the unit and all of a sudden have 2 sig figs, right? This cannot be. So the thing is that these zeros right here, the first 2, are not significant. They are placeholder zeros. So this number has 2 sig figs. The same thing is here, the 0 point. That's just a placeholder 0. So they are not significant. So the 5 to 7. So I have 3 sig figs here. 3. Because again, I can change the 0.5 to 7 liters to 527 milliliters. All right. So the problem comes with trailing zeros. And trailing zeros may or may not be significant. And you say, oh, great. Which one is it? Well, let's look at these numbers. These numbers, we have just zeros at the end. So zeros at the end, we're going to say right here are not significant. But these zeros here at the very end are. So how do you know? Here is the rule. If you have a 0 at the end that has to satisfy two things, it has to come after a decimal and after a number. So 0, one more time, has to come after a decimal and after a number is significant. That's when zeros are significant. Otherwise, they are not. It's going to be an estimate. When I say 500 mils, it means it could be 400 mils, 600. If somebody says, please pour 500 milliliters into a graduated cylinder, if you pour 400, 600, it's fine. If somebody says 500 meters, 400 meters, 600 meters, that's fine. They are already saying that this is the estimated digit. The zeros are not significant. They are just showing you the magnitude. So again, 250 mils could be 240, 260. It is that 5 here that's uncertain. The 0 is important. It's showing the magnitude, but it's not significant. Whereas these zeros here, they come after a decimal, after a number, and tells me something about the equipment I'm using, right? If I say 500.0 meters, I am using a ruler with, every meter mark. And then I am imagining the decimeter tick marks. Is this making sense? So this one has 1 sig fig, 2 sig figs here, and this is 4 sig figs here. And here we have, let's make sure we see this. Here, this 0 at the end is significant. It's after a decimal and after a number. And so we have 6 sig figs here. And then this 0, it doesn't matter where the number is. It can be right in front or it can be way in the beginning. So it's after a number, after a decimal. And we have 1, 2, 3, 4, 5 sig figs. Okay, you got that? These are the rules for sig figs. And also an exact number that you actually counted, saying I have 48 crayons. That's an exact number. You have exactly 48 crayons. That's an infinite number of sig figs because we can say we have 48.0 crayons. And so exact number has an infinite number of sig figs. And also that means definition. So saying there is 100, let's put 1,000 meters equals 1 kilometer. Well, that's a definition. There is exactly 1,000 meters in a kilometer. That's an infinite number of sig figs. Okay, so let's practice really quickly. How many significant figures are in each measurement? Really fast. Let's do this. So here we have 4 numbers, 4 digits, and everyone is a non-zero. That's easy. Here we have 4. Right here, next example, let's look here. Well, we have this 0. It's just a leading 0. And this 0 is after a decimal point, but it's not after a number. So these zeros do not count. So the 2 and a 3, yes, so we have 2 sig figs here, right? Okay, 890, where this 0 is after a number, but not after a decimal point. So this 0, no. And 8 and 9, yes, so again, 2 sig figs. 2 sig figs right here. How are you doing? Is this okay? All right, let's go here. Well, this 0 here is a sandwich 0. So yes, significant, but this 0 is after a number, not after a decimal, so nope. So we have 4 sig figs here. Let's go more. Oh, this 0 at the end now is after a decimal and after a number, and this is my sandwich 0, so they count. So 5 sig figs. And over here, I'm going to say, okay, this is my sandwich 0. This 0 is after a decimal and after a number. These are also sandwich 0. So I have 1, 2, 3, 4, 5, 6, 8 sig figs here, right? Next example, well, I have to deal with these zeros. So all these zeros at the beginning are just placeholder zeros. So no, no, no. This zero, yes, it's after decimal, after a number. So I have 3 sig figs. And right here, the beauty of scientific notation is that you will know exactly how many sig figs you have, just count, because now this 0 is after a decimal and after a number, so I have 3 sig figs. And the other zeros, that means are not significant. So scientific notation is great. Okay, right here, 72, the question is, you don't know. It could be 2 or infinite. You could count exactly 72 people at a party. If you counted 72 people, there is 72.0, there is 72.00 people, so that's an exact number. Or you can estimate. You can say, this is about 72, that means, 72 milliliters, it could be 71, 73. Remember, that will be your tick marks, which are every 10 milliliters apart, and you are estimating the 1 milliliter thing. So it could be 2 sig figs, or it could be infinite, depending. Actually, you need more information here. And right here, I'm going to say these zeros, no, that's an estimate, so 1 sig fig. How did you do? Can you quickly determine how many sig figs a measurement should be reported with, and how many sig figs, in each measurement? Are you ready to do some calculations using sig figs? I think so. So there's 2 separate set of rules. One set of rules is for addition and subtraction, and a separate set is for multiplication and division. Let's think about the theory behind addition and subtraction. Let's say we have coffee, a nice cup of coffee, and we have about 200 ml in that cup. Okay, if I add 1 drop, which is 0.05 milliliters, are you going to say the new volume is still about 200 mLs, or is it going to be 200.05? Will that 1 drop make a difference in your cup? Will you notice that 1 drop difference? You wouldn't. So why would you report it? So the new volume is still 200 mLs, because 1 drop did not make a difference. So how do we deal with addition subtraction? Okay, so let's do some 2 examples. So the reason I have a little calculator on the side here is your calculator will not tell you correct number of sig figs. So watch out. Okay, you gotta use your brain here. So let's do here. So here we have, let's do addition. So we will have 3.834 centimeters if I have to add these 2 measurements. Okay. But let's take a step back. If I have 1.234 centimeters and 2.6 centimeters, well, that tells me that these measurements were done using very different pieces of equipment, 2 very different rulers. Okay, so 1.234, that means I am uncertain about the 4. I do not know about the 4. And 2.6, I'm using a ruler with only 1 centimeter tick marks, right? And I estimated the 0.6, so I am uncertain about the 6. So this is my tens place. So I carry down. Remember, my uncertainty carries down. If I am uncertain about the tens place, who cares about the hundreds, thousands place, right? So that means I am already uncertain about the 8. If I'm uncertain about the 8, does this 4 matter to you? No, it's the same thing. Like if I have about 200 ml in a coffee cup of my coffee, if I add that 1 drop, does it matter? It doesn't. So I do not care about this 4, because I am already uncertain about the 8. So if I'm uncertain about the 8, I have to report that. So I look at the number after it, and here is 3. And if it's digit 0, 1, 2, 3, 4, I'm going to leave the 8 alone. But if it's 5, 6, 7, 8, 9, I'm going to round up. So this measurement will be reported as 3.8 centimeters. How is that? Okay, let's do some subtraction here. If we do our calculator, where here will be 5, right? 7 minus zeros, this is 7 point, this will be 6. So we will have 46.775 meters. And again, let's think through this. Here I am uncertain about this 5. And here I am uncertain about the 0. So my uncertainty will carry down. So that means I am uncertain about the 7. I'm also uncertain about the 5. But if I am uncertain about this 7, does this 5 matter? No. So I want to show that this is my uncertainty. So I'm going to look at the number after. Oh, it's 5. So I have to round up. So I'm going to say my new measurement is 46.78 meters. All right? Is this making sense? So remember, addition, subtraction. You line up your decimal points, and then you show your greatest place of uncertainty. That's what you have to show. All right? Okay. Let's do multiplication and division. Multiplication and division has a whole different set of rules. So let me explain to you why. Let's say we have this beautiful sheep pasture. I'm going to put a fence around it, and I'm going to want to know how many square kilometers my sheep pasture is. So this is going to be a big pasture. Okay, I know the numbers will be like, oh, this is big. I know. Want my sheep to run around. Okay, so I'm putting a fence and I'm going to measure things. So the length will be 4.35 kilometers and the width is 2.5 kilometers. So let's figure out the area that my sheep will have. So remember from geometry class, area equals what? Length times width. All right, so area equals, well, my length is then 4.35 kilometers times 2.5 kilometers. And this, if I plug this into a calculator, I'm going to get that this is 10.875 kilometers squared. All right, there you go, 8.75. Let's think about this. Remember, I am uncertain about the 5 here. I am uncertain about the 5 here. So this 4.35 can also be, 4.34, couldn't it? And the 2.5 can also be 2.4. So if I do this, if I have 4.34 and 2.4 kilometers, if I plug this in a calculator, my area of my pasture will be 10.416 kilometers squared. Okay, but it also could be, remember that 4.35 can also be 4.36. And the 2.5 could be 2.6, couldn't it? So I plug this into a calculator and I get 11.336 kilometers squared. So the thing is that my area is actually, given my uncertainty in measurement, somewhere between these two numbers. One of them is the low-end estimate and one of them is the high-end estimate. So do you have to do this for every multiplication and division problem? You have to do a low-end and high-end? That will be a lot of time wasted. So how do we deal with this? Well, we're going to deal with this like this. So 4.35 is 3 sig figs, right? 2.5 is 2 sig figs. If I multiply 3 sig figs times 2 sig figs, my answer has to have the least number of sig figs as one of the numbers. So my answer has to have 2 sig figs. So 3 sig figs times 2 sig figs, what's the smallest number? Smallest number is 2. And that means my answer has to have 2 sig figs. So let's write this down. We have, copy this over. So if I have 10.875 kilometers squared, and I want to show this with 2 sig figs, well, these numbers then will be certain, and this is my estimated one. Well, no, this is my certain estimate. I have to look here at 8 behind. I have to have 2 sig figs. So then my answer is 11 kilometers squared. right? So let's look here. This is 11 kilometers square is certainly right between these two, my low end estimate and a high end estimate. So there we go. So that's how you're going to deal with multiplication and division using sig figs. The least number. Addition, subtraction, you're going to add up, line up your decimal points and carry that over that uncertainty. All right? I think you got this. I hope you learned something new. Thank you for watching and see you next time.